G'day, my name's Steve and this is Reevesy Workshops. Today we're going to continue on overhauling the Blowfly's axle pump. So this is axle pump part 2. The next step is a good lesson in how sometimes you need to be prepared to compromise, particularly when you're working with worn machinery. So what you see here is the gland nut sitting in the 4-jaw chuck, and I want to true it up as best as I can so that when I bore out the recess for the O-ring boss, the O-ring boss is going to set concentrically with the pump ram. But the problem is the pump ram's been rubbing on the gland nut for so long it's overlaid the hole a little bit. So you can see that oval in the way the needle's moving, and we have an 8 foul error. So what I did was move the jaws around until I can minimize the error, and then the error that was there was evenly spread, as you can see here. Now if I take that away, start up the machine, what you will notice is this edge is actually running pretty true. Yes, the bore's a little bit out, but it's running fairly true as well. So that's the best setup I can get for it. There's a little bit of side play when I press the ram in the bore, so I reckon that's going to be accurate enough to go along with the next stage. To machine that bore, I'm going to use the smallest boring bar I have that's going to fit the hole size, and it just so happens it's one made of tool steel. So I need to zero it against the face. You can see I previously machined that square. So I'll use this bit of paper. When I see it's held captive, I know that's the 0 point, but I also have to take into account the thickness of the paper. So off camera there, I've just zeroed my dial, taking into consideration the thickness of the paper. And I'm just going to touch on here. It's actually pretty close, so I'm going to leave it there, zero the dial. Then I need to go 3/4 of an inch bore, or 19 millimeters, at a 1/8 depth, or 3 millimeters depth. My telescopic gauges are too small, or rather too big, to measure this small hole that I'm doing. So another way you can do it is by using a set of inside calipers. This requires feel, and as such there can be errors, but for what we're doing it will be accurate enough. So all I need to do is measure it with the mic. And although you can't see it, it's saying 570, so I've got to go another 130. So I now have it bored out to 3/4 of an inch, or 750 thou. As you can see here, in fact it's 1 thou oversize, but that's good enough for me. You see it just goes in there. I'll deburr it, carry on with the next job. I've made a start on making the little gland box for the O-ring. So you can see I've pre-drilled a hole. That's to be bored out, which we'll do shortly. In the meantime, I'm just going to put the register on. So I've marked the line out here with the calipers. Now I'm going to machine this down to 3/4 of an inch or 19 millimeters to fit that recess, because this body will be silver soldered onto the gland nut. This one's easier to do, of course, because we're doing an external machining maneuver. So I'm actually doing this freehand. I haven't got the saddle engaged in the feed at all. And of course I can just measure it with the micrometer. That's telling me I've got 850 at the moment, so I've got exactly 100 to go. I've machined the outside down a little bit so I can silver braze this on to the other part, polished it up a little bit with some memory cloth. Now I've just touched the boring bar on that hole and zeroed it, and now I'll bore this out to size. So I've just taken a few light cuts. I'm able to use a telescopic gauge this time to measure things. When I do measure things, I find that I am within a foul of where I need to be, which is great news. In a previous video I showed you how to make the axle pump ram, and we talked about some mathematics I did to ensure that I'd got the groove for the O-ring in exactly the right place. Well, doing this one is very similar. So you can see this little diagram here I've made, working out where everything should sit. Here's our little boring bar I'm going to use. So what I've done under a magnifying glass, I've got it to just touch the surface, zeroed it in, and like before I have a digital dial indicator, I should say analog dial indicator, and I'll use that for getting the correct depth. And it's basically a repeat of what I'd done before. I've got the groove machined up now. It's so small it's difficult for the camera to show it to you, which is a bit of a shame, but anyway, we got there in the end. So now I'm going to part it off and finish machining it. A little tip when you're parting off, so the job doesn't fall down into the bowels of the lathe and get damaged, I put this bit of rod through here, and now I can part off and the job will fall onto the rod. So let's do that. There we go, no damages. When I machined the groove, I found that I didn't have a lot of clearance with this little tool. So you'll see from there to here wasn't really deep enough. So the groove was only 82 foul deep when it should have been 89. I thought, well, maybe 7 foul isn't going to make a lot of difference. But on consulting people that are more experienced with O-rings than me, they suggested that the O-ring is going to be squashed too much and is likely to get damaged and wear out very quickly. So they suggested I went back and ground the tool down slightly, so you can see here where I've ground it down using a combination of the grinder and my Dremel. Then I got my depth gauge here. That's the depth I need to go, and if I very carefully put it on here, I can see I've got plenty of clearance. So now I've got enough clearance to go back and machine the groove to the correct depth. Machining the new groove is a bit of a problem because you saw me before part the O-ring boss off. So now I have to put it back in the lathe and machine it, and I need it to run true. Otherwise things are not going to work properly. So how did I get it true like this? Well, you can't put it back in the 3-jaw because unfortunately the way a 3-jaw is designed, if it's a self-centering type, these threaded bits have a little bit of play in them, and what happens is it doesn't tighten up on the job exactly in the same place. So that means you can't guarantee that this is concentric. So that means you need to put it in the 4-jaw and get it concentric that way, because these chucks are all jaws I should say are all independent from one another. So it's called a 4-jaw independent chuck, and I can move them around to get this central. So how do I get it central? Well, the first thing you need to do is use some sort of device to get it by eye where you need it to be. So I've got this, the back of this tool, which is probably the easiest way to do it. And then what I do is you rotate 180 degrees. So each jaw is numbered. So what I tend to do is I'll put jaw number 1 at the top, and then I'll measure what the job is doing with jaws 2 and 4. And of course it'll be slightly out, so the job is going to move a little bit back and forth as you turn it. So you'll see the job close to the back of this, and then you'll see a gap. So what you do is you turn it till you see the gap, and then you slightly move the job half the distance of that gap. Then you go back to the starting point, adjust the tool, move it again 180 degrees, see a gap, halve the gap, and you'll do that a few times until you get it pretty good. Then you want to start with number 2 jaw and do exactly the same thing. That will then get it 90% of the way where you need it to be, and it's a quick way of getting the job concentric. The next stage is to put your dial indicator on the job. Now you saw in my last video that I actually dialed the bore because that's what I needed to be accurate. I still need this to be accurate, but it's better if you can do it on the outside rather than the inside, because the dial indicator is really designed to be used on the outside. It should also be like this, but you see I've got it on a slight angle, and that's because I need the dial to miss the chuck jaw. So it's not quite as accurate when it's on an angle than if it was like this, but it's good enough for what I want to do. And it's the same procedure as before. So you have number 1 at the top, turn it 180 degrees, then move it half the distance go back to your starting point, zero it, turn it again. If it's moved off the zero, halve the distance again until you get it reading zero both ends. Then you turn it 90 degrees, so you got number 2 sitting upright, and you repeat the process. Now you'll see the needle is moving here, but actually from there to there is 1 foul, that's 2 foul, that's 3 foul. So you can see the needle's moving half a foul. Well, that's more than accurate for what we need to do. And if I turn on the machine, you'll see it's pretty good. There's almost no movement there at all, so I'm going to leave it at that, and I'll deepen that groove. I'll do that all off camera because you saw how I made the groove to begin with, and basically this is just a repeat of what you've seen before. Now another little tip, notice I've got these copper jaws on here, and that's to stop you marking the work and keeping your nice finish. So they're always handy to have as well. I've faced it off in the collet now and got it to width. The dark area in the center there you see is the groove. So far so good. Now we'll silver braze the parts together. I don't like to waste silver solder, it can be quite expensive stuff. So as I get to the end of a rod, I'll put it in something like these multi-grips, and then I can use it to solder with, which should have just enough to solder this joint. So I've cleaned it, fluxed it, now we'll braze it. So it takes a while for it to warm up, but the telltale sign that you're close to what you want is the flux changes from white to clear liquid, and then you know you're fairly close to temperature. And as the material starts to go red, as you can see there, then you can touch the rod on there, see if it's going to run, and if it does run, feed it in carefully and then move the heat around a bit so you can see the solder flow all the way around. So I'll let that cool now and we'll put it in the pickle bath. While I'm waiting for the pickle to do its job, I'm going to make a new drive pin. First thing I'm going to do is replace this bronze bush that you see here, quite worn. So I use my micrometer and my pin gauge to accurately determine what the size of the new bush should be. From there I was able to make up this diagram, so we'll go and make it. Here's the finished product. You can see the O-ring sitting in there. I put a little bit of oil on the O-ring as this end is Probably going to run dry if the O-ring on the ram doesn't bypass water. Made up a little test piece here. Runs beautifully. I can feel the O-ring rolling, that's why it's jerking. So taking that little bit extra out on the groove was the right thing to do. I can feel that O-ring sealing and doing what it should. I just fitted the gland nut up and the ram with all the O-rings in place to do a trial fit, and I can easily move the ram in and out of the pump body, which is excellent. If I can do it by hand, that means the engine's going to have no trouble operating the pump. So things are looking good. So we'll go on to the next stage now and sort the eccentric rod out. Things are progressing really well with the pump. I'm pleased on how things are going, especially those O-rings. First time I'd put an O-ring in a groove like that, and pretty pleased with the way it went. So in part 3 we'll move on to the eccentric and start finishing things off. See you then.